Okay, so this is 17b question 2c. I need to construct a probability distribution table. Okay, so the values that p hat can be are 0, 1/5, 2/5, 3/5, 4/5, or 1. And the probability that p hat equals small p hat, I need to work out the probabilities. So I'm choosing 5, and my probabilities change because when I choose my first, I can choose a male or I can choose a female. The male will be 12 out of 20 and the female will be 8 out of 20. But when I choose my second member, I've now only got 19 to choose from, and since my sample is small, not a large population, I can't use the binomial. I have to draw a tree diagram or work it out. So I'm not going to draw a tree diagram because that's 5 leaves, but I need to think about what it could be. So this would be 11 out of 19, and that's 8 out of 19. And this is male, that's female. So now we've got 10 out of 18 and 8 out of 18, etc., etc., etc. Okay, so to have no males, that's actually employing a female, 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 selecting, not employing, which is really 8 on 20 times 7 on 19 times 6 on 18 times 5 on 17 times 4 on 16. 1, 2, 3, 4, 5. And that should be the probability in here. Okay, so that's 8 by 7 by 6 by 5 by 4 over 20 by 19 by 18 by 17 by 16, which is what this is. And that gives me, move the decimal point 3 spots to the left, so 0.003611. Okay, so that goes there. If I now think about the other end is having 5 males, male, 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 which is 12 times 11 times 10 times 9 by 8, all over 20 by 19 by 18 by 17 by 16. And that's going to be 0.0511. And that goes in that spot there. Okay, so what about the other spots? Where I've got 1 male, it could be a male and 4 females, or a female and a male and 3 females, or a female. So this is really the combinations of 5C1, which is going to be 5 times. So that's going to be 5 times having 1 male, so that's 12 out of 20, and then the rest females, 8 by 7 by 6 by 5, all over 19 by 18 by 17 by 16. So in actual fact, it doesn't matter, I just need to have a 12, an 8, a 7, a 6 and a 5, because when I rearrange the order, the multiplication stays the same. So that gives me a 5 at the front, and then 12 for the 1 male, then 8 by 7 by 6 by 5 with the same denominator, and that gives me an answer of 0.0542. Okay, now when I'm looking for 2 males and 3 females, so 2 males and 3 females will be, how do I select 2 out of 5? And I'll have 20 by 19 by 18 by 17 by 16. And I'll have 2 males, so there's going to be a 12 and an 11. And then there will be an 8 by 7 by 6. And I might use Pascal's triangle to come up with these. So 1, 1, 1, 2, 1, 1, 3, 3, 1. 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So that's going to be 10 times. So I'm going to take this, I'll have a 10, and I will get rid of the 5, and I will add in 11. And that's going to be the next number, 2384. 2384. So this is what that comes out. This is 2 males, and that is 2384. Now I'm looking for 3 males, and it's going to be 10 again. So now we're going to do this all on here. So I've got this is going to be 3 males. So 10 times, I get rid of the 6 because I've only got 2 females, and I need to add in a 10. And that's going to give me an answer of 0.3973. And to get 4, I'm now going to go back to 5 again, but I've got 4 males. So if I grab my, I'll keep this one. I'll make that 5. And I'm going to get rid of one of the females, and then I'll have it times by 9. And that gives me an answer of 0.2554. 0.2554. And that is my probability distribution for p hat. Just to repeat, I needed to draw a tree diagram to work out the probabilities because my sample, my population was small, only being 20 people. So that when I chose one person, the probability changed considerably, so I couldn't use the binomial to make the decisions to work out the probabilities. And that ends up being my probability table.